Now let's do a redox calculation. So in this particular sample we have 0.5 grams of iron wire. It's dissolved in sulfuric acid and it's titrated with 0.2 molar potassium permanganate, and we need a volume of 26.8 ml. Calculate the percentage purity of the iron wire. So the first thing we're going to do is we're going to draw a diagram. So in our diagram, here is our conical. We have some iron wire. And remember, this is not pure, so we can't find a mole. It's dissolved in 100 ml of sulfuric acid. Now the purpose of doing this is to convert all of the iron into iron 2 ions, which we can then use in our reaction. Now we take the entire sample and we titrate it against potassium permanganate, which has a concentration of 0.02 molar and a volume of 26.8 ml. So it's titrated against the whole thing, and this, remember, is now iron 2 ions. Now the significant difference between these calculations and the acid-base calculations that you've done earlier is the actual equation. The equation is much more difficult. So we go to our data sheet and we pick out the permanganate equation. So that is permanganate plus 8 hydrogen ions plus 5 electrons goes to manganese 2 ions plus 4 water. Now, the oxidation half equation is iron 2 goes to iron 3 plus an electron, which we've also got off our data sheet. Now remember, we have to make the electrons the same because you cannot have leftover electrons. So we're going to times this by 5, and then we're going to add it together to get our overall equation. Permanganate plus 8 hydrogen ions plus 5 electrons plus 5 iron 2 ions goes to manganese 2 ions plus 4 water plus 5 iron 3 ions plus 5 electrons. Now electrons cancel out, which is always a good thing, otherwise we've made a boo-boo. So the overall equation is permanganate plus 8 hydrogen ions plus 5 iron 2 ions goes to manganese 2 ions plus 4 water plus 5 iron 3 ions. Now when you were doing this equation, what you would see is this deep purple colour will go a brown colour. Now let's get started. Once we've got our equation, we always have to find a mole. So in this case we can find the number of moles of permanganates. So if you look back here, number of moles of permanganates will equal the number of moles of KMnO4, which equals CV, which is equal to 0.02 times 0.0268. And this comes out to 5.36 by 10 to the negative 4 moles. So the number of moles of iron 2 will equal unknown over known times the moles of the known, which is permanganate. So that equals, the unknown was 5 over the known, which is 1, times 5.36 by 10 to the negative 4. So this will come out to be 2.68 by 10 to the negative 3 moles. So if you look at the two equations, all of the iron 2 ions came from this equation here. So as you can see, the equation is in a 1-to-1 ratio, so the number of moles of iron will be the same the mass of the iron will equal number of moles times formula mass, which is 2.68 by 10 to the negative 3 times 55.85, and it gives us a mass of 0.1496 grams. Now the question asks us to find the percentage purity. So the percentage purity equals mass of the pure over mass of the impure times 100, which is 0.1496 divided by 0.5 times 100, which is 29.9%. Checking significant figures. So going back to the question, this one's got 4, this one's got 3, this one here's got 3, this one here's got 2. So our final answer should be in 2 significant figures, which equals 30%.